Asteroid 2024 YR4 discovered in December 2024 has garnered significant attention due to its potential close approach to Earth on December 22nd. 2032 in this video will cover three main areas. First, the current risk assessment of it. Second, the cutting-edge methods used to track and evaluate such objects. And third, the innovative strategies and related discoveries that inform our potential responses. Asteroid 2024 YR4 was discovered on December 27, 2024 by the ESO Observatory in Chelyabinsk. Unique characteristics have made it a focus of scientific study. This object, estimated to be between 40 and 90 meters wide, has caught the attention of experts because even a relatively small asteroid of this size could cause significant regional damage if it were to explode in Earth's atmosphere. Recent calculations by NASA's Jet Propulsion Laboratory suggest a 1.6% chance of an impact on December 22nd. 2032, a figure that, while low, demands thorough investigation. The significance of the impact probability lies in the asteroid potential. Destructive power and air burst from this asteroid is estimated to release energy comparable to roughly 8 megatons of TNT, which translates to an explosion several hundred times more powerful than the Hiroshima bomb. Historical events serve as stark reminders. For instance, the 1908 Tunguska event caused by a smaller body leveled vast stretches of forest in Siberia in a single devastating blast. Such evidence highlights why even a small probability must be taken seriously. This asteroid follows a highly elliptical orbit that brings it close to Earth periodically before swinging back toward the outer solar system. That's why astronomers rely on advanced models that account for gravitational influences from the planets and the effects of solar radiation. Pressure telescopes and radar systems worldwide work in unison to track 2024 YR4's position and velocity over time. The collaboration among various research institutions and international agencies ensures that the most current data is integrated into the models. This gives us confidence that the predicted risk levels is based on robust science. Each close approach, like the one projected in 2028, provides an opportunity to gather new information that could either confirm the current risk or adjust it. Instruments like NASA's Near-Earth Object Wide Field Infrared Survey Explorer use infrared technology to detect the heat signatures of asteroids, enabling the discovery of objects that may be too dark to see in visible light. The evidence gathered from these instruments allows scientists to estimate the size, composition, and trajectory of objects like 2024 YR4, providing a crucial first step in risk assessment. In addition to optical telescopes, radar technology plays a pivotal role in monitoring. NEO's radar systems transmit radio waves that reflect off the surface of an asteroid, yielding detailed information about its distance, speed, and rotation. This method has been successfully used in the past to image and track various near-Earth objects, giving researchers the precision needed to calculate orbits with high accuracy. These radar measurements serve as essential evidence in refining the models that predict how an asteroid's path might evolve over time. Computer simulations are another key component of modern risk evaluation. These simulations integrate observational data with models that account for gravitational forces from planets and the subtle effects of non-gravitational forces, such as the Yarkovsky effect. This effect, where an asteroid's orbit changes due to the way it absorbs sunlight and re-emits energy as heat, can significantly alter an object's trajectory over extended periods. By including such factors, scientists can produce a detailed and dynamic picture of an asteroid's future path, reducing uncertainties and improving predictive accuracy. Risk evaluation is further enhanced by using tools like the Torino scale. This scale assigns a value based on the likelihood and potential consequences of an impact. While the scale currently indicates that 2024 YR4 poses a low immediate risk, the dynamic nature of its orbit means that it will be continuously reassessed as new data is collected. One of the most promising mitigation strategies is a kinetic impactor technique, which was successfully demonstrated by NASA's DART mission in 2022. In this approach, a spacecraft is deliberately crashed into an asteroid to alter its trajectory. The evidence from DART shows that even a relatively small impact can produce measurable changes in an asteroid's course if executed with precision, which offers concrete proof that we have the capability to deflect an object long before it becomes a danger to Earth. The fundamental physics here is straightforward. Applying a force at the right moment can create a significant shift over time, emphasizing the importance of early detection and intervention. In parallel with kinetic impactors, scientists are exploring innovative methods such as laser ablation. High-powered lasers can be aimed at an asteroid surface to vaporize material, creating a jet effect that slowly modifies its trajectory. Laboratory experiments and computer simulations provide compelling evidence that laser ablation could be a viable option, particularly if we have a substantial lead time. This method illustrates how advances in energy technology can be repurposed for planetary defense, offering a non-invasive means of altering an object's path. Another approach is the concept of the gravity tractor. Unlike methods that rely on direct impact or energy transfer, a gravity tractor involves positioning a massive spacecraft near the asteroid. Over time, the spacecraft's gravitational pull exerts a subtle but persistent force, gradually nudging the asteroid onto a safer trajectory. The theoretical models and small-scale tests conducted so far suggest that this method is especially promising when dealing with objects that are discovered well in advance. It's a strategy that emphasizes patience and precision rather than brute force. Beyond these technological interventions, our understanding of mitigation has also been enriched by studying past near-miss events and related discoveries. For instance, the Chelyabinsk meteor of 2013. While far smaller than 2024, YR4 provided invaluable data on how atmospheric explosions behave. The detailed recordings of its energy release and the resulting shock waves have informed models of airburst impacts, enhancing our ability to predict the outcomes of similar events. These real-world observations serve as practical evidence of the destructive potential of even modest-sized objects, underscoring the need for effective mitigation strategies. Other related discoveries, such as the comprehensive studies of asteroid Apophis, have played a critical role in shaping current defense plans. Apophis, once a source of considerable concern, have been closely monitored over time, and its evolving risk profile has helped scientists refine their models and techniques. The insights gained from tracking Apophis have allowed us to improve our data collection, simulation methods, and overall readiness in the face of potential impacts. Additionally, ongoing advancements in space observation technologies continue to improve our ability to detect and characterize near-Earth objects earlier and with greater precision. The upcoming NEO Surveyor mission, scheduled for launch in 2026, will significantly enhance our detection capabilities for potentially hazardous asteroids. This space-based infrared telescope is specifically designed to find 90% of near-Earth objects larger than 140 meters, filling critical gaps in our current detection networks. International cooperation remains vital to planetary defense efforts, with organizations like the United Nations Office for Outer Space Affairs coordinating global response protocols through the International Asteroid Warning Network and the Space Mission Planning Advisory Group. These collaborative frameworks ensure that when potential threats are identified, the world's scientific community can rapidly share data and coordinate observation campaigns. Public awareness and education also play crucial roles in planetary defense, as demonstrated by events like Asteroid Day, held annually on June 30th, which commemorates the Tunguska event while promoting asteroid science and defense initiatives. Citizen science projects have likewise contributed valuable observations through programs that allow amateur astronomers to participate in asteroid tracking efforts. As we continue to monitor 2024 YR4 and other near-Earth objects, each new discovery and technological breakthrough brings us closer to developing a comprehensive planetary defense system capable of protecting Earth from potential impacts. The lessons learned from studying this particular asteroid will undoubtedly inform future research and preparedness strategies, helping humanity become more resilient against cosmic hazards. Our growing understanding of asteroid composition and behavior, combined with advancing deflection technologies, suggests that within the coming decades we may achieve the capability to reliably protect our planet from most impact threats. This represents one of the most remarkable intersections of space science and practical engineering, where theoretical astrophysics meets real-world crisis prevention. The story of 2024 YR4 serves as both a reminder of our vulnerability to cosmic events and a testament to human ingenuity in developing solutions to existential challenges. As monitoring continues and new data is collected, the scientific community remains vigilant, ready to update assessments and recommendations based on the latest evidence. This dynamic process of observation, analysis, and preparedness exemplifies science at its best: collaborative, evidence-based, and focus on safeguarding humanity's future. Thank you again for your interest in this important subject, and remember that planetary defense is truly a global endeavor where every nation and citizen has a stake. Stay engaged with the latest developments as our understanding of 2024 YR4 and other near-Earth objects continues to evolve through ongoing research and space exploration initiatives. Thank you for joining us on this comprehensive exploration of asteroid 2024 YR4. We hope this video has informed, inspired, and excited you about the incredible progress in planetary defense and the scientific ingenuity that drives it. Stay curious, stay informed, and thank you for watching.